So here it is. Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter amines. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them. Um, Also, please install our Sapience education app application where we shall upload some important homework questions based on the previous year KCET exam. Also, in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter, which shall be obviously helpful for your KCET exam. So here it is told that amines behave as. So amines, it can be a 1 degree amine in the form of RNH2, or it can be a 2 degree amine like R dash NHR, or it can be RN R dash. So it can be a 3 degree amine also. So it can be 3 degree amine or 2 degree amine or 3 degree amine, but every amine group, it has got a lone pair on the nitrogen atom. So hence it can behave as a Lewis base. It can behave as a Lewis base. Since why? Since it can give the electron pair. Since it is capable of donating, it is capable of donating an electron pair. So hence it is acting as a Lewis base. So hence option D is the correct answer. Then here it is said that arrange the following in the increasing order of their basic strengths. So here we have so the rule is that 3 degree amine is more basic, or it has more basic strength than 2 degree amine, and which is more basic than 1 degree amine, which is more basic than NH3. Since why? When more number of alkyl groups are attached to the nitrogen atom, or when more alkyl groups are attached, uh, then um, it has the plus I effect, which has the uh, positive inductive effect. So hence it will increase the basicity of the lone pair. So it means that more substituted amines, are more basic due to the greater availability of the electron density on the nitrogen atom, due to greater availability availability of the electron pair on the nitrogen atom. So simply it means that when more alkyl groups are attached, it increases the electron density of the lone pair on the nitrogen atom. So hence the basic strength will increase. Hence the basic strength increases. So it means that here the 3-degree amine is NCH3. So it means that NCH3 whole thrice is having the highest basic strength. So here it means that NCH3 whole thrice has the highest basic strength. Less than that is 2-degree amine, which is CH3 whole twice NH. Then less than that is 1-degree amine, which is CH3 NH2. And less than that is the ammonia NH3. So it means that the expected order will should be this one only. It should be the expected order. But here the rule is that when there is more alkyl groups, then there is a more steric hindrance e- effect. So hence the basicity of 3-degree amine will decrease. So here the rule is that even if the electron density in 3-degree amine is higher, but um, there is crowding of alkyl groups, but there is more crowding of the alkyl groups, which causes the steric hindrance, which causes steric hindrance, hindrance, and which decreases the basic strength of 3-degree amines, which decreases the basic strength of 3-degree amines. So hence, therefore, the correct order is, therefore, the correct order of the basic strength, it is that NH3 is the least basic. Then we have CH3 whole thrice NH3 is CH3 whole thrice N, which is the 3-degree amine. Then we have the 1-degree amine is CH3 NH2. Then we have 2-degree amine CH3 whole 2 NH. So hence it means that option A is the correct answer. So here it is told that CH3, CH2, CH3, CH2, Br, it will react with aqueous potassium hydroxide with heat. It will produce the compound A, and then the compound A on heating with acidified KMnO4, that will give the compound B, which on further heating with NH3, that will give the compound C, and which on further reacting with bromine and alkali, it will produce the compound D. So here when CH3 CH2 Br reacts with aqueous KOH, then it will, then from KOH it will give the OH minus as the nucleophile, OH minus as the nucleophile, which will attack on this Br, and then it will form CH3CH2OH. It means ethanol will be formed, which is the compound A. Now here we have to uh, find out which is the compound D. The final product we have to find. And then when ethanol will react with KMnO4, the presence of H plus, then this alcohol will be oxidized to carboxylic acid. So it will form CH3COH, which is the acetic acid. And then when NH3 will react with CH3COH, then it will form CH3CONH2, which is the compound C. Then when Br2 will react with CH3CONH2, then it will form CH3NH2, which is the compound T. So option C is the correct answer. Then here it is told which of the following forms propane nitrile as the major pro product. Which one of the following forms? So propane nitrile, it is what? Propane nitrile is CH3CH2CN. This is called propane nitrile. So it will, which of these compounds will form CH3CH2CN as the major product? So now when CH3CH2Br, that will react with alcoholic KCN, then it will give cyanide as the nucleophile, which will attack here, and then it will form CH3CH2CN and plus KBr. So hence it should we should use ethyl bromide. We should use ethyl bromide and alcoholic KCN. So option A is the correct answer. Then here it is told that the correct sequence of reactions to convert para-nitrophenol into quinol involves. So now para-nitrophenol, it is this one, OH here, and here we have the NO2 group, and which will react with SnHCl, and this NO2 will be, the NO2 group will be reduced to the NH2 group. It will form okay. So the NO2 will be reduced to NH2, and then it will react with NaNO2 HCl, then it will form diazonium chloride. It will form diazonium chloride, which is N2 plus Cl minus, and then it will re react with H plus H2O, so which is called acid hydrolysis. So on acid hydrolysis, it will form uh, quinol, which is para hydroxyphenol. Para-hydroxyphenol it will form, which is called as quinol also. So the first step is reduction. Then the next step is diazotization. And And then we have acid hydrolysis. So it means that the option A is the correct answer. Then here it is said that the conversion of uh, metanitrophenol metanitrophenol to resorcinol is now re- resorcinol means it is metahydroxyphenol. Metahydroxyphenol is called as resorcinol. Now metanitrophenol, which is NO2. So first it will react with SnHCl, which is the re reduction. So the first step is reduction. So the NO2 group will be reduced to NH2 group. It will be NH2 and here OH. Then the next step is it will react with NaNO2 with HCl, which is called. So the second step is diazotization. Diazotization. Then here the benzene diazonium chloride will be formed, which is the OH, and here N2 plus and Cl minus. Then it will react with H plus H2O, which is called the acid hydrolysis. Acid hydrolysis. And then here it will form resorcinol, which is metahydroxyphenol, which is resorcinol. So it means here also the first step is reduction, the second step is diazotization, and the third step is acid hydrolysis. So option D is the correct answer. Then here it is told benzyl amine is a stronger base than aniline because. Now benzyl amine, that means it is, we have amine, benzyl amine is so here it is told it is a stronger base than aniline. Aniline is like this NH2. So here it is told that the benzyl amine is a stronger base than aniline. Since why? Here the lone pair on nitrogen atom in the case of aniline, it is involved in the resonance with the benzene ring, and here the lone pair of nitrogen is not involved in resonance with the benzene ring. So here in case of aniline, the lone pair is delocalized delocalized, but here it is so it means that it is involved in resonance with the benzene ring, but here it is not involved in here this lone pair is not involved in resonance with the benzene ring. So here the lone pair is more available. So it means that benzyl amine is a more stronger base than aniline. So it means that here it is told the lone pair of electrons on the nitrogen atom in benzylamine is delocalized. No, it is wrong. The lone pair of electrons on the nitrogen atom in aniline is delocalized. Yes, it is true. Option C, it is told the lone pair of electrons on the nitrogen atom in aniline is not involved in resonance, which is false. Then option D, benzylamine has a higher molecular mass than aniline, which is false. So option B is the correct answer. Since here, as you know, that the lone pair on nitrogen atom in case of aniline is Localized, it means that it is involved in resonance with the benzene ring. And here it is told that which one of the following gives amine on heating with amide. So, so the rule is that the treatment on the treatment of amide with Br2 in the presence of aqueous solution of KOH or NaOH, um, an amine is obtained. An amine is obtained uh, um, having lesser number of carbon atoms than that in the re- reactant. It means that here amine is obtained which is having one carbon less, which is one carbon less than in the amide. So here simply it means that RCONH2, here R means if we have some alkyl group, so it is the amide. So on reacting with Br2KOH, which is a- aqueous, so it is called Hoffman bromamide re- reaction. Hoffman bromamide reaction. So when so it will be changed to RNH2. So here it means, as we can see, that it has one carbon less than the amide group. So which one of the following gives amine on heating with amide? So Br2 in the presence of aqueous KOH. So option A is the correct answer. Then it is told that an aromatic compound A, which is C7H9N, on reacting with NaNO2HCl at 0 degree Celsius forms benzyl alcohol. Benzyl alcohol, which is this, and nitrogen gas N2. The number of isomers possible for the compound A. So here we have to find out the number of isomers of the compound A. Number of isomers of A. Now the here we have benzyl amine, which is CH2NH2. So it reacts with NaNO2HCl at 0 degree Celsius to form benzyl alcohol plus N2. So here we have to find the number of isomers of this compound A, which is whose molecular formula it is C6H5 then CH2NH2. It means that it is obviously C7H9N. Okay. So we have to find out the number of isomers of A. So one isomer is itself A, and the other isomer is CH3, and here NH2. Or we can put this, so we can put this NH2 group in the ortho or in the meta or in the para positions. So we can put the NH2 group in the ortho position or in the meta position or in the para position. So I can place NH2 here also. So it means that we will have four, okay, or I can keep, or I can take one more isomer, which is like this, which is NH and CH3. So it means that we can have 5 isomers of the compound A. 5 isomers we can have. So option A is the correct answer. Then here it is told the correct sequence of the reactions to be performed to convert benzene into M-bromo into metabromo aniline. So now metabromo aniline, it means that here we have aniline, which is which is amino benzene, and bromine should be placed in the meta position. Then it is told correct sequence of the reactions to be performed to convert benzene, which is this benzene C6H6. So we have to react it with concentrated HNO3 with H2SO4 with concentrated nitric acid with sulfuric acid, which is called as the nitration reaction. So here we will have nitrobenzene. Nitrobenzene will be formed, and then it will react with bromine water. It will react with bromine water, which is called bromination. Bromination. So here meta bromo nitrobenzene will be formed. Metabromo metabromo nitrobenzene will be formed, and which on further reaction with SnHCl, which is called as the reduction step. So here this NO2 group will be reduced into NH2. So it will form NH2Br. So hence it will form metabromo aniline. So metabromoaniline will be formed in the final step. So it means the steps are: first is nitration, the second is bromination, the third step is re reduction. So nitration, bromination, and reduction. So option C is the correct answer. Then here it is told that the reactant P on reaction with CH3MgBr, which is a Grignard reagent, with H3O plus, it means acidified, means we have to use some acidic solution. Then the reactant P will be converted to the product R. Then the compound R on reaction with heated dilute NaOH, it will form 4-methyl pent 3 in 2-on. So it will form 4-methyl pent 3 in and 2-on. So it is pentane, pent, and so 2-on and 3-in and 4-methyl. Here we have methyl. So it is like this. So it is 4-methyl pent 3-in 2-on. So it is the final product which should be formed. So here the thing is that so when we have to heat with dilute NaOH, then it is called as aldol condensation. Aldol condensation. and with heat. So here actually we should start with ethane nitrile, ethane nitrile, which is the reactant P, ethane nitrile. Since why? When it will react with CH3 MgBr in the presence of an acidic solution, then it will form CH3COCH3, which is acetone, which is the compound R, and which on reaction with dilute NaOH, there will be aldol condensation, and then it will form CCH3, CH3, then C, then here that will be OH, and here it will be CH2, then CO, CH3. So it will form 4 hydroxy. So it will form 4 hydroxy, 4 methyl. So it will be 1, 2, 3, 4, 5. So it is 4 hydroxy, 4 methyl pent and 2 on, pent and 2 on. And when it is heated in the presence of an acid, then it will lose mm, H H2O. There will be dehydration, and then from here it will remove one H2O. One H2O will be removed, and here one double bond will be formed. It means that it will convert into an alkene here. So then finally it will form methyl, which is 4 methyl pent 3 in 2 on. It will form, which is also called as mesitile oxide. Mesitile oxide. So it means the product, the reactant P should be ethane nitrile. So option C is the correct answer. Then here it is told of the following amides which will not undergo Hofmann bromide reaction. So the rule is that only primary amides, or I can say 1-degree amides, 1-degree amides will undergo Hofmann bromide reaction. Hofmann bromide reaction. So in the option A, it is CH3. So primary amides or 1-degree amides, it means that it should be of the form RCONH2. Then only it is called 1-degree amide. Mm, okay. So in the option A, it is CH3CONH CH3. So it is not a 1-degree amide, it is a 2-degree amide, or I can say it is a secondary amide. And in option B, it is CH3CH2 CH2CO NH2. So hence it is a 1-degree amide, or it is a primary amide. And then in option C, it is told it is CH3CONH2, which is also a 1-degree amide, or it is a primary amide. So hence it is 1-degree amide, so it will give Hofmann bromide reaction, and the this one will also give Hoffman bromamide reaction. And in the option D, it is C6H5CO NH2. It means it has a benzene ring, and we have CONH2. So this one is also a 1-degree amide. So it will also give Hoffman bromamide reaction. So here only the option A will not give the Hoffman bromamide reaction, since it is a secondary amide. So option A is the correct answer. Then it is told, in the sequence of the following reactions, the starting compound P is. So finally here ortho bromobenzoic acid has been formed. Ortho bromobenzoic acid. Now the starting compound P, now here the starting compound P on reaction with Br2SnHCl, which is the uh, reduction, it will form the compound Q, which on reaction with NaNO2, अच्छा अच्छा ठीक है ठीक है। So here it will react with NaNO2 HCl in the presence of H2O H3PO2. Then it will form the compound R, which on reaction with KMnO4 in the presence of an alkali, it will form ortho bromobenzoic acid. So it means that here we have oxidation. Here we have oxidation. So it means that here alkaline KMnO4 has been used. So it means that COH will be formed from CH3. So it will be orthobromotoluene, which is the compound R. And here NaNO2HCl is used with H2OH3PO2. It means the compound Q should be CH3Br and NH2 here. And so it means the compound P here, bromination is also used. So it means that the compound P should be, so here it is re reduction when SnHCl is used. It means the here the nitro group is reduced to NH2. So it means that here we should have NO2 and here CH3. So it means that the compound P should be uh, para nitrotoluene. Para nitrotoluene should be. So option B is the correct answer. Then here it is said that in the given set of reactions, here 2-bromopropane, 2-bromopropane. So here we have 2-bromopropane, which is CH3CHBr CH3, which is 2-bromopropane. Now that will react with alcoholic silver cyanide. Now silver cyanide will give isonitrile as the nucleophile, which will attack here. Then it will form the compound X, which will be CH3 CHNC CH3. and then it will react with lithium aluminum hydride. So here hydrogen will be added. Simply it will here hydrogen will be added, so it will form CH3 CH NH CH3 CH3, which is the product Y, which is the compound Y. So we have to write the IUPAC name of this product Y. So it will be N N methyl N N methyl propan 2 amine. N methyl propan 2 amine. So option B is the correct answer. Then it is told in the following sequence of reactions, the compound A on reduction forms the compound B, which on reaction with HNO2 forms CH3 CH2OH, which is ethanol. Ethanol is formed. Now here, so it means the compound B should be CH3 CH2 NH2. Since why here it will form CH2OH and it will form H2O plus N2. And here reduction, it means that here lithium aluminum hydride should be used. So CH2NH2 is formed. It means that the compound A should be CH3CN. Since why, then CN group will be reduced into CH2NH2. So it means the compound A should be ethane nitrile. Ethane nitrile. So option B is the correct answer. Then it is told that an organic compound A on reduction, an organic compound A on reduction gives the compound B, which on reaction with trichloromethane, which is CHCl3, which is called as chloroform also, which will react with trichloromethane and caustic potash, means KOH, to form the compound C. Now the compound C on catalytic reduction gives N-methyl benzenamine. It gives N-methyl benzenamine. Then the compound A is. So we have to find the compound A. Now N-methyl benzenamine, which is which has the benzene ring, and here here we have NH2, N-methyl, so it will be NHCH3. So it is N-methyl benzenamine. Now N-methyl benzenamine is formed by the catalytic reduction. It means that here lithium aluminum hydride is used. It means that the compound C should be an isonitrile. So since the NC group, which is isonitrile, it will be reduced into NHCH3 by lithium aluminum hydride. So it means the compound C should be NC. Okay. So it is benzene isonitrile. Now now it is told that the compound C, which is benzene isonitrile, that is formed by reaction of the compound B with uh, chloroform and KOH. So hence it means the compound B should be a- aniline. It should be aniline. Then which is formed from the compound A by reduction. Now reduction, it means here SnHCl is used. So using SnHCl, the NO2 group is reduced to NH2 group. So it should be nitrobenzene. Should be nitrobenzene, which is the compound A. So the compound A should be nitrobenzene. So option A is the correct answer. So then here it is said that Gabriel thalamide synthesis is used in the preparation of primary amines from thalamide. Which of the following reagent is not used during the process? So HCl is not used. HCl is not used to prepare amine, to prepare the RNH2, which is the amines from thalamide. From thalamide in Gabriel thalamide synthesis. But KOH and aqueous NaOH and alkyl halides are used. Now, thalamide, it means, now the thalamide structure is like this. So it is called the thalamide. So from thalamide, we will obtain the primary amines. Primary amines means 1 degree amines, means it should be of the form RNH2. So it will be formed from thalamide. Here we can use any strong alkali which is KOH or NaOH can be used, or alkyl halides can be also used. So it means that HCl is not used. So option B is the correct answer. Then it is said that the correct order of increasing basic nature for the bases NH3, then CH3, NH2, and CH3 whole twice NH is in the aqueous solution is. So now, since when we have methyl group which is attached to NH2, then the methyl group has the plus I effect, which is the positive inductive effect. So it will increase the electron density of the lone pair on the nitrogen atom. So hence, when more number of methyl groups are attached, it means that it will increase the basic strength of the amines. So simply the rule is that when more substituted amines, if I have more substituted amines, more substituted amines are more basic in nature. Simply it means that when more CH3 groups are attached, it means that the uh, plus I effect will be increased, and it will and hence the lone pair on nitrogen atom, it is more available. So hence it is more basic. So when the lone pair is more available, it means that that amine is more basic. So then here, mm, so it means that CH3 whole 2 NH is the most basic, and NH3 is the least basic. So the least basic is NH3 and the most basic is 3H3 whole 2 NH. So it means that option D is the correct answer. It is the required increasing order of the basic strength. Then it is said that the reaction of benzene diazonium chloride with aniline yields yellow dye. The reaction of benzene diazonium chloride, which is N2 plus Cl minus, which is called the benzene diazonium chloride. So it reacts with aniline NH2 to form uh, para aminoazo benzene. It means that it will form N double bond N, and here one benzene ring, and here NH2. So here hence it will form para amino azo benzene. It means option B is the correct answer. Then it is told that which of the following is more basic than aniline? Now aniline is the the benzene ring with NH2. Now this is aniline, and it has been asked which one is more basic than aniline. Now option A is diphenyl amine. Now diphenyl amine, it means that it is like this NH, which is called diphenyl amine. Here we have two phenyl groups which are attached to the nitrogen atom. It's called diphenyl aniline, diphenyl amine. Okay. Then option B we have triphenyl amine. Here, three phenyl groups will be attached, which is triphenylamine. And C is we have para-nitro aniline, para-nitro aniline. And D is benzyl amine, benzyl amine. CH3, CH2NH2, benzyl amine. Now here in the option A, so in case of a- aniline, the lone pair on nitrogen, it is delocalized with resonance in the benzene ring. So here this lone pair is not so available, since why it is delocalized due to resonance with the benzene ring. So it has got resonance with benzene ring. And here also in diphenylamine, the lone pair in nitrogen atom, it is also delocalized with the two benzene rings. So here it is also lesser available than aniline. So it is also lesser basic than that of aniline. And in the case of option B, here also the lone pair on nitrogen atom, it is delocalized with three benzene rings. So here it is even lesser basic than aniline. So it is less basic than even diphenylamine, lesser basic than diphenylamine also. And here in the option C, here we have NO2 group which has got minus R effect and minus I effect, which has negative resonance effect and negative inductive effect, since the NO2 is an electron withdrawing group. Electron is an electron, NO2 is an electron withdrawing group. So hence the he- and here also the lone pair on the nitrogen atom, it is delocalized with the benzene ring. And since an electron withdrawing group is attached, so it is even lesser available. Here the lone pair is much lesser available. So it also is less basic than aniline. Here also it is less basic than aniline. And in the option D, here the lone pair on nitrogen atom, it is not delocalized with the benzene ring, since there is no conjugation is involved of this lone pair with the benzene ring. So there is no resonance. There is no resonance of this lone pair with the, there is no resonance of the lone pair of electrons with the benzene ring, with the benzene ring. So hence this lone pair is more available than in case of aniline. So it is more basic than aniline. Hence benzenamine is more basic than aniline. So it means here option D is the correct answer. Then it is said that which of the following will be the most stable diazonium salt. So the first one is CH3N2 plus X minus, which is methyl diazonium halide. And in option B, it is C6H5, that it means that it is benzene diazonium halide. And in option C, we have ethane diazonium, ethane diazonium halide. And in option D, we have benzene, or we have, yeah, benzene diazonium halide, or we can say it is phenyl methane benzene or phenyl methane diazonium halide. Now here, this diazonium halide, here it is stabilized by the resonance, since here there will be conjugation is involved here. Here there is a resonance effect. Here there is a resonance effect. So hence this positive charge can come here also. So it means that this diazonium salt is stabilized by resonance. This diazonium halide salt is stabilized. It is stabilized by resonance. So it means that uh, the option B, which is benzene diazonium halide, is most stable due to the resonance effect. Due to resonance effect. So option B is the correct answer. And here it is told that which of the following is least soluble at 298 Kelvin? Which one is least soluble in water at 298 Kelvin? So here the rule is that aromatic amines aromatic amines are insoluble in water. Aromatic amines are insoluble in water. The reason is reason is that the larger hydrocarbon part, or the larger phenyl group, or the large benzene ring which is attached, the large benzene ring which is attached to the NH2 group, it tends to it tends to oppose the formation of the hydrogen bond with H H2O. It tends to oppose the formation it tends to oppose the formation of hydrogen bond with H2O. So hence aromatic amines are insoluble in water. And here you can see in the option D, it is obviously an aromatic amine, which is also called as a- a- aniline. So aniline is an aromatic amine, so it will be insoluble in w- w- water. It is insoluble in water. So option D is the correct answer. Now here it is said that if aniline, if aniline, which is this one, if aniline is treated with 1:1 mixture of concentrated HNO3 and concentrated H2SO4, para-nitroaniline, para-nitroaniline and meta-nitroaniline are formed in equal amounts. So when concentrated HNO3 and H2SO4 is used, this process is called as nitration. So the reason has been asked that this is due to M m- meta directing property of the NH2 group. No, it is wrong. The protonation of NH2 which causes deactivation of benzene ring, meta and para directing pro property of the NH2 group, and isomerization of some para-nitroaniline into meta-nitroaniline, which is wrong. So actually here option B is the correct answer. Mm, So here the reason is that the NH2 group in aniline is ortho and para directing group. Since why it will increase the electron density in the ring, since it will have plus R effect, which is the positive resonance e- effect. So hence it will increase the electron density in the ortho and in the uh, para positions. So the NH2 group in aniline is ortho and para directing, and it is activating. So it and okay, it is so it activates the benzene ring, and while in presence of an acid, while in presence of an acid, the NH2 group gets protonated. The NH2 group gets protonated. NH2 group gets pro- protonated to form the a- anilium uh, to form the anilium ion. So here anilium ion is formed, which is like this NH3 plus. It means simply one H plus ion will be added the uh, uh, with the NH2 group here. So hence it will form PH NH3 plus. So it will be called as the anilium uh, uh, ion. Now here the anilium ion, it will decrease the electron density in the benzene ring. So here it will decrease the electron density in the ring, in the benzene ring. So it is a meta directing group. So this NH3 plus, it is a meta directing group. Meta directing group. So it will decrease the electron density in the benzene ring. It means that it will cause deactivation of the ring. It will cause deactivation of the ring. So hence the reason is that it will cause protonation of NH2, which causes deactivation of the benzene ring. So option B is the correct answer. Then it is told which of the following has the lowest boiling point. Now, in case of the NH2 group, here there will be hydrogen bonding with H2O. So it will have hydrogen bonding with H2O. So its boiling point will be high. And in case of HCOH, which is the formic acid, so it will also have hydrogen bond with H2O. So here also the boiling point will be high. And in case of e- ethanol, ethanol will also have weak hydrogen bonding with H2O. So here also there will be hydrogen bonding here. So it will also have slightly high boiling point. Only in case of CH3O CH3, here there will be no hydrogen bonding with H2O. Here there will be no hydrogen bonding with H2O. So hence its boiling point will be very low. So its boiling point is the least. So option B is the correct answer. Then here it is told that nitrobenzene nitrobenzene on reaction with Br2 Fe Br3, which is ferric bromide with bromine bromine with ferric bro bromide, it will give the compound P, which on reaction with Sn and considered HCl, which is called as the reduction, so it will form the compound Q, which on reaction with NaNO2 and dilute HCl and in with heat, then okay, no, it is not heated in, it is here 0 degree Celsius or 273 Kelvin is used, then it will form the final product R. So we have to identify which one is the final product R. So when Br2Fe Br3 is used, so here the bromine will be added. Now since NO2 it has minus R effect and minus I effect, so it will decrease the electron density in the benzene ring. So it means that NO2 is a meta directing group. NO2 is a meta directing group. So it means that the so it will form meta bromo nitrobenzene. Um, Meta bromo nitrobenzene will be formed, which is the compound P. And then when Sn considered HCl is used, then here the NO2 group will be reduced into NH2. It means that it will form metabromo aniline. Metabromo aniline will be formed. And then when it is reacting with NaNO2 and HCl, then it will form diazonium chloride. Diazonium chloride will be formed. Diazonium chloride, which is N2 plus Cl minus and bromine here, and on which on heating in the presence of H2O, that will form mm, metabromophenol. So simply this N2 N2Cl will be replaced with OH, and then it will form Br. So it will form uh, metabromophenol. So it means that option A is the correct answer. Then here it is called that the Hinsberg reagent is. Now the Hinsberg reagent is C6H5, which is the benzene ring, and SO2Cl. So it is called the Hinsberg's reagent. So it means that option A is the correct answer. Then it is told that product B is the product B is, we have C6H5, which is the benzene ring, and CH2Cl. So we have, so it is called as benzyl chloride. So it will react with NH3 to form the product A. Simply it means that from here NH2 will attack here, and then the chlorine will be replaced with NH2 group. So it will form so it will form phenyl methanamine, which is the compound A. Then it will react with CH3Cl, CH3Cl, 2CH3Cl. So it means that it will form NN. So it means here the two hydrogens in NH2 group will be replaced by two methyl groups here. So it will form CH2, N, CH3 and CH3. So it is the final product B. So its name is N N N comma N N N dimethyl N N dimethyl phenyl methanamine. Methanamine. So option A is the correct answer. Then it is told the method by which aniline cannot be pre prepared is. The method by which aniline cannot be prepared is. So here first one is called nitration of benzene. So nitration, it means that here we should use HNO3, concentrated HNO3 with H2S4, which is the nitration reaction. So it will form nitrobenzene. Nitrobenzene will be formed, and followed by reduction with SN and concentrated HCl. So it will form, so here simply the NO2 group will be reduced into NH2 group. So it will form aniline. So aniline will be formed here. So option A can be used to prepare aniline, and option B, it is told degradation of benzamide, with bromine in alkali solution, Br2KOH. So when Br2KOH is used, then also it will form aniline. Since why? The rule is that RCONH2 will get converted into RNH2 when alkaline bromine solution is used. Okay, so it will form aniline. So option B also can be used to form aniline. And option C, it is told that reduction of nitrobenzene with H2PD in ethanol. Reduction of nitrobenzene with H2PD in ethanol, which is ETOH, or I can say C2H5OH. So here also it will form here also it will form aniline. Since here the NO2 will be reduced into NH2 group. And in option D, it is told potassium salt of phthalimide. Potassium salt of phthalimide. Now, phthalimide is this, as we know. So the potassium salt, it means that here N minus K plus, okay, sorry, So here we will have N minus K plus, which is the potassium salt of thalamide. Now that is is treated with chlorobenzene. That is treated with chlorobenzene, followed by the hydrolysis with aqueous NaOH solution, followed by the hydrolysis with aqueous NaOH solution, H2O. Okay. So here actually there will be no reaction. So we can't use the second step, since the in the first step only no reaction will happen. So the second step can't be used, since in the first step only no product will be formed. The reason is that chlorobenzene, which is this one, chlorobenzene does not undergo nucleophilic substitution reaction. Nucleophilic substitution reaction, since here the CCl bond, here it has got partial double bond character due to resonance with the benzene ring. Since here the chlorine has got lone pairs, so with the benzene ring it can take part in resonance. So this lone pair is in conjugation with the benzene ring. So here it can have resonance. So it can take part in resonance. So here this carbon chlorine single bond which is formed here, it can have a partial double bond character. So hence it will not undergo re reaction with the potassium salt of thalamide. Potassium salt of thalamide. Since why? So the reason is that chlorobenzene does not undergo nucleophilic substitution reaction, since the carbon chlorine bond in chlorobenzene in PHCl, or I can say C6H5Cl, has partial double bond character, partial double bond character due to the resonance with benzene ring, due to the resonance with benzene ring. So hence there will be no reaction. So hence option D can't be used to form aniline. So option D is the correct answer here. Then here it is told that a hydrocarbon A, which is C4H8, on reaction with HCl gives a compound B, which is C4H9Cl, which again on reaction with 1 mole of NH3 gives the compound C, which is C4H11N, which is the compound C. And on reacting with NaO2HCl followed by treatment with water, the compound C yields an optically active compound D. So th this one will react with NaO2HCl followed by treatment with H2O and heat. Then it will form an optically active compound D. So the final compound D is an optically active compound. So we have to identify this compound D. So here four carbons should be there, in the in compounds A, B, and C. And so in compound D also there should be four carbons only. So in all the options we have four carbons. Um, so it means that if D is an optically active compound, it means the compound C also should be optically active. Compound C also should be optically active. So hence it means the compound C should be CH3 C, so it should have four carbons and one nitrogen, one NH2 group here. So it should be this compound which is optically active. Since why here we have four different groups which are attached to this carbon atom. So it is the chiral carbon, so it is optically active. So it is the chiral carbon which is optically active. So now, therefore, the compound A, that is C4H8, C4H8, that it means that it should be an alkene. An alkene, it should be butene, should be butene only. So hence, therefore, the compound A, that should be but1ane, this CH3, CH2, CH, CH2, it is but1ane, and then it will react with HCl to form C4H9Cl. So simply here we will have hydrohalogenation. We will have hydrohalogenation reaction. So here we have to use the Markovnikov's rule. We have to use Markovnikov's rule. It means that the carbocation will be formed here and the carbon ion will be formed here. So H plus will be attached here and chlorine Cl minus will attack here. So it means that it will form CH3, CH2, CHCl, CH3. So it means that the compound C and compound B all should be optically active. Since why here also we have four different groups which are attached to this carbon. So this is also optically active. So the compound B is also optically active. And then when it reacts with 1 mole of NH3, then it will then the NH3 will attack here and it will remove this chloride ion. So then it will form CH3, CH2, C, NH2, H and CH3 plus HCl. So this is the compound C, which is an optically active only. And then it will react with NaNO2 HCl, NaNO2 HCl, and then it will form diazonium chloride, which is CH3, CH2, C, then here N2 plus Cl minus, which is the diazonium chloride. And then when it reacts with H2O and heat, then this N2Cl will be replaced by OH. N2Cl will be replaced by OH. So here the final product D, which is formed, that is nothing but that is okay. So the final product D, which is formed, that will be CH3, CH2, C, and here this N2Cl will be replaced by OH. So here OH, and here obviously we have CH3 and here H. So it is the optically active compound D. So it means option B is the correct answer. Then it is told in carbyl amine test for primary amines, the resulting foul smelling product is. So in the carbyl amine test or in carbyl amine reaction, the 1 degree amine or primary amines, here the primary amine that reacts with chloroform, that is CHCl3, in the presence of an al alkaline solution KOH to form RNC, which is alkyl isocyanide, which is alkyl isocyanide, and it forms KCl and H2O. So this isocyanide which is formed, it is foul smelling. So all alkyl isocyanides are foul smelling compounds. So hence here the isocyanide which is formed here, it is CH3NC, CH3NC, which is in the option A. So it means option A, which is which is the only isocyanide among all these four. So it means the methyl isocyanide, it will be a foul smelling compound. So option A is the correct answer. Then here it is said that secondary amine is, so secondary amine, or it is also called 2-degree amine. It means when two alkyl groups are attached with the nitrogen atom in the amine group. So in the amine group, if two alkyl groups are attached, if two alkyl groups are attached with the nitrogen atom, then only it is called secondary amine or 2-degree amine. It means that R, NH, R dash, it should be of this form. So in option A, it is told compound with an NH2 group on the carbon atom in number 2 position, which is wrong. Then option A, why it is wrong? Since suppose we have NH2 group in the second carbon, then it is not a secondary amine. It is a 1-degree amine only. Since why with NH2 only one alkyl group is attached, then it is called as a 1-degree amine or primary amine. It is called primary amine. And then option B, it is told a compound in which two of the hydrogens of NH3 has been replaced by organic groups. Yeah, it is true. So in case of NH3, if the two hydrogens are replaced by two alkyl groups, then only it is called a 2-degree amine or secondary amine. In option C, it is told an organic compound with two NH2 groups, which is wrong. A compound with option D, it is a compound with two carbon atoms and an NH2 group, which is also wrong. So option B is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year KCET exam on the chapter amines. So still any doubts if you have, then please write that in the comments section. We shall obviously clarify them. And also please install our Sapience education application, where we shall upload some important questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.